You hear the term the cloud every single day, right? But have you ever really stopped to wonder, where is it? It sounds so abstract, maybe floating up in the sky somewhere. Well, the truth is, the cloud has a physical address. It lives in a room that looks a lot like this one.
I mean, think about it for a second. That last photo you uploaded, the last document you saved, where did it really go? It feels like it just poofs into the internet, somehow existing everywhere and nowhere all at once. But that's not what happens. Not at all.
It actually goes right here, into a server. This machine, sitting in a very real physical place, is the basic building block of the entire internet and the cloud you use every day. Your data, it lives on a hard drive inside one of these boxes.
And that's really the first big idea we need to wrap our heads around. The cloud is physical. It is not some misty, magical concept. It's built with metal, with silicon, and with a whole lot of electricity, all humming away inside buildings scattered all over the globe.
So, what is a server anyway? Well, the easiest way to think about it is as a super powerful, specialized computer. Its one and only job is to store, process, and serve up data all day, every day, 24/7. When you load a website, get an email, or stream a movie, a server somewhere is the engine making it all happen.
But, just like any other tool, not all servers are created equal. They come in different shapes and sizes, or what we call form factors, and each one is designed for a specific job. You'll mostly run into three main flavors. We can break these down with some simple analogies. First, you've got your tower server. This is basically a desktop PC on steroids. It's perfect for a small business running simple tasks. Then there's the rack server, which looks kind of like a high-tech pizza box. It's designed to be stacked really efficiently in data centers. And finally, the blade server. Think of it like a book on a high-tech bookshelf. It's all about packing the most power you can into the smallest possible space.
So, okay, they look a little different on the outside, but what truly makes a server different from your PC at home is what's on the inside. And it all comes down to one word: reliability.
Unlike your desktop, servers are just packed with specialized gear. We're talking about having 2 power supplies, special memory that corrects its own errors, hard drives you can swap out while the machine is still running, and processors built to just run and run and run without ever stopping. Let's dig into that power supply thing, because it's a huge deal. Your PC has one cord. If it gets unplugged or the power supply fails, that's it, game over. A server, on the other hand, has 2. They're both running all the time. If one fails for any reason, the other one just takes over instantly. The server never goes down, and neither does the website it's hosting. And it's the same idea with the memory. Servers use this special stuff called error-correcting code, or ECC RAM. You see, tiny little electrical spikes or fluctuations can cause random data errors that would totally crash a normal computer. Well, ECC memory finds and fixes these little errors on the fly, automatically. It's what keeps your favorite streaming service from crashing right in the middle of the season finale.
Okay, so we've got these incredibly powerful, super reliable machines, but a single server isn't enough to power, say, a social media site. To build the cloud for real, you need to organize hundreds or even thousands of them together. And you don't just put them on a desk, they get installed into a server rack. Think of it as a standardized filing cabinet, but instead of paper, it's designed to hold computing power securely and efficiently. This is the key to scaling up a data center.
And setting one up is a really careful process. First, you have to make sure the empty cabinet is stable and bolted down. Then, you always put the heaviest gear, like the battery backup, the UPS, at the very bottom. That keeps it from tipping over. Servers slide in on rails so you can pull them out easily for maintenance. And finally, every single cable is managed meticulously. That's not just to look neat, it's absolutely crucial for proper airflow. But getting the hardware into the rack is only half the battle. To keep everything running smoothly, you have to create the perfect environment. And that, well, that's a science all on its own.
It all starts with this number, around 20 degrees Celsius. That's the sweet spot for a server room. Too hot, and components will literally cook themselves and fail. Too cold, and you risk condensation, which is just as bad. This temperature isn't for human comfort. It is purely for the survival of the hardware.
And beyond just the temperature, there are some really strict rules. You need plenty of empty space behind the rack for hot air to get out. You have to cover all the empty slots with these filler panels to force the cool air to go where it's needed. Power has to be perfectly stable, managed by a power distribution unit. And of course, safety is non-negotiable, with specialized fire suppression systems ready to go at a moment's notice.
So let's zoom back out. From a single tiny component to the environmental rules for an entire room, all of this stuff, all this work, it all comes together for one single purpose.
You see, a server room isn't just a closet full of computers. It's a living, breathing ecosystem. The environment, the temperature, the power, the airflow is just as critical to keeping our digital world online as the actual computer chips themselves.
So, the next time you save a file to the cloud, this is where it's going. Not into thin air, but onto a spinning hard drive inside a server being cooled by a perfectly controlled environment inside a real building somewhere on Earth. This is the physical reality of our digital lives.
Everything we do online lives in these rooms, but we're creating more data every single second, and that demand is just growing exponentially. So the real question is, what's next? How do we build a physical cloud that's bigger, faster, and way more efficient to power whatever's coming in the future? That is the next great challenge.